we are going to be talking about what we call measures of variability. Now, remember that when we started looking at summarizing data, I indicated that actually, first of all, I indicated that in summarizing data, what you are trying to do is to find a single value. So you're trying to find a single value that is the best description of the data, right? Single value that gives you a best description of the data. All right. Now, in order to find that single value, statistician indicate that more likely you may locate that single value at the center of the distribution. Distribution. You may locate that single value at the center of the distribution, and the measures of locating that single value are called measures of central tendency, right? Now we learn about the mean, we learn about the median, and then we learn about the mode. So those are the three most common measures of central tendency, right? The three most common measures of central tendency are the mean, the median, the mode. And that's what we've been doing in section 2.3. And then we also learn about a special mean called the weighted mean, and also the mean with frequency, right? Those with frequency. So these are the things that we have done. Now, in order to completely describe a data, you don't only need the center of the distribution, you also may need to know how spread out. So how spread out the data values are. And here I've coined a term that I call value distancing, or values distancing, coining it from social distancing, right? Are the values close to each other, or are they spread out away from each other? All right, so today we're going to be focusing on how do you measure how spread out the values are from each other. All right, and I'm calling it value distancing. I don't think anybody uses that word. Okay, now in that sense, there are so many different names that we give to the word variation. So we can say measures of variation, we can say measures of variability, we can say measures of dispersion, and we can say measure of spread. So these are all the same name. So instead of saying measures of variability, oh, I was going to write variation. Instead of saying measures of variability, we can say measures of variation. All right. Measures of dispersion, measures of spread. So these words are used interchangeably. All right, these words are used interchangeably, and their goal is to measure how spread out the data values are. Value distancing. All right, so that is our focus today. We're trying to measure how spread out the data values are from each other. All right, we'll be focusing on the four most common measures of variability. So we'll be focusing on four most common. One is the range. So we'll be learning about the range. Two is the variance. Three is the standard deviation. And four is called the introductory. interquartile range. All right, so those are the four most common that we're going to be looking at. We will look at the first three today. Then on Friday, we're going to start talking about the interquartile range. All right, but today we will look at the range, the variance, and then the standard deviation. That's how much we can do in time that we have. Okay, now somebody may ask, well, why do we need to bother ourselves not only to stop at the center of the distribution? Why do we need to go ahead? All right, so I gave these two data that you have here. Data set A, so data set A, and then data set B. Okay, now it happens that the mean is 6, the median is 6, the mode is 6. Oh, data set B, the mean is also 6, the median is also 6, the mode is also 6. So when you look at these two data sets, if I've not shown you the individual values and I just showed you that, oh, there's a data set that has a mean of, there are two data set that's the same mean, mode, all the same, they are same numbers, right? Without seeing the data, you may think that they have this, then if they have the same mean, same same mean, same median, same mode, you may think that they have, then the values are the same. However, when you look at the numbers that we've been given, you would see that data set A, set A ranges from what, 4 to 8, right? Set B ranges from 1 to 11. So you would see then that if you start to take the range into account, the range of values into account, then you can say, well, it looks like set B, it's more spread out, and set A is less spread out. So even though the mean, median, mode, it's telling you the same information, that they both have the same information, right? It's missing a whole very important picture of describing the data. It's missing the fact that one data set is more spread out than the other. All right. So when we talk about measures of spread, we are looking at how can we capture one single value that can measure how spread out each data set is. So when we do the calculation, we expect that a number for A will be lower, a spread for A will be lower than a spread for B, or a spread for data set B should be higher than a spread for A. In other words, knowing the data set, knowing the measures of central tendency is not enough. You need to know how spread out the data is. So when you are summarizing data, make sure that you are not only telling us, describing only the center, but also describe in summarizing data, also describe how spread out the data is. Talk about the center, talk about the spread of the data. Because if people don't see your data with their eyes, right, the only way they can know what is happening within the data is by you reporting the spread of the data in a single value. Okay, so always take note that we are not only focusing on the center of the data, but we're also focusing on how spread out the data is. When you are describing the data, those two come together to give a much complete picture of the situation. All right, so like I told you, these are the four most common. So to describe the measure or the amount of variation or variability in the set of data, the four most common one, the range, the variance, the standard deviation, and an interquartile range. All right, like I told you, we're going to do the first three today, and then on Friday, we're going to look at the interquartile range. Okay, so why don't we start with the range? So the range, as you've seen the range somewhere when we're dealing with frequency distribution, how to find a class width, which says a range over the number of classes. All right. So the range is just the difference between the largest and then the smallest data value, or the maximum minus the minimum, the highest value minus the lowest value. So we see in this town, the low town, the lowest house there is 91,000 and 97,000. The highest house price there, the most expensive house price there is 2 million, right? So for us to find a range, you're going to do 2 million minus the, what? Oh, sorry. I did 95, it should be 93, right? This is the lowest. So this minus 93, that gives us a whole wild range. Okay, so we can interpret that range to say that the difference between the most expensive and then the cheapest house in Lowtown is that. Okay, now note that the range is using what we call the extreme. When we say extreme values are the maximum and then the minimum. Those are on the extreme ends of the data. All right, so the range usually use extreme values, and for that reason it's not too much the best measure of central tendency, the measure of spread. Okay, so on Blackboard, the note, when you go to course notes, you're going to see measures of variation. All right, when you go to course notes, then it says measures of variability, measures of good. One of it is a PowerPoint that I'm talking on right now. The other are like a set of questions. Okay. So we have the range. Now, let me see. So once again, the range do have problem because you could have like two data set giving you the same range, but you see that like here the range is 8, the range is 8, but you could see that there is the what is in between the range are two different numbers. All right, so the range is not always very good. Okay, the range is not always very good. Even though we use the range in our daily vocabulary, usually when they are reporting, let's say temperature, usually temperature is reported, they will say, oh, the daily low is that, the daily high is that. Or maybe you're traveling into some area, let's say you're traveling to Africa, all right, and then you asking your friend, or maybe you're traveling to Ghana because I'm from Ghana, right? So you say, oh, how is the temperature there? I could say, oh, the temperature range from this number to that number. So the range is also used in different ways, but in terms of the actual data calculation, it's not the best. Okay, so why don't we look at the next one? So I indicated that the measures of spread, one is a range, two is a variance, and three is a standard deviation. Standard deviation. Okay. In order for us to understand the variance, we have to understand the word deviation. The reason is that the variance and then the standard deviations, they are linked. They are linked. All right. They are related. All right. One and two are related. All right. So first, let's understand the word deviation. In statistics, usually we say, so to consider the variance and the standard deviation, we first have to understand the meaning of the term deviation. When we say deviation, we actually mean deviation from the mean. All right, so deviation from the mean is the data value minus the mean. Basically, that's all it means. So deviation means the data value minus the mean. That's all. All right, not vice versa. Take note, data value first, mean second. All right, this comes first, this comes second. The order is important. Data value minus the mean. So when we talk about deviation, data value minus the mean. Now, let's look at this data we have here. The mean is, so here, say the mean is 5, right? And then we have data. If the data value it's 1, then we say deviation will be 1 minus 5, and that will be negative 4. Now, what does this negative 4 means? This negative 4 means that the data value of 1, so the value of 1 is 4 units below the mean. All right, it's 4 units below, minus, so 4 units below minus 4 means 4 units below the mean. Okay, so that is a deviation. What about if the data value, suppose the data value is, let's say, 8, then the deviation is going to be 8 minus 5, that gives you 3. It means that the value of 8 is 3 units above the mean. Okay, so a positive deviation means that that value is above the mean, and negative deviation means that value is below the mean. All right, so the population deviation the formula is the same, the value minus the mean, data value minus the mean. All right, so that is the meaning of deviation. All right, so I have this example here. All right, so you're given like data of number of some items sold. Okay, so you can list the numbers in a vertical way. Okay, now note that deviation means the value or the data value minus the mean. So you need the mean first, right? You need the mean. So here, when you add all the numbers, that is 250, and then the mean will be 250 over 5, that is 50. So you're going to do 20 minus 50, 40 minus 50, 50 minus 50, 60 minus 50, 80 minus 50. So this answer is what we call deviation or deviations, right? So 20 minus 50 gives you negative 30. So these are the deviations. Now, in statistics, and actually in math, and this is true for all numbers, right? The sum of deviations, the sum of deviations from the mean, it's always equal to 0. The sum of deviations from the mean, it's always equal to 0. When you take any set of numbers and then you subtract the mean from each number, the new set of numbers you get is called deviations. The sum of all deviations would always give you 0. The sum of deviation is always 0. So this is a multiple choice question, a very famous multiple choice question. The sum of deviations, it's always equal to 0. Now, if that is the case, all right, let me actually come over here. Okay, so if that is the case, that the sum of deviations is always 0, let's take another set of numbers. This is a number of traffic citation in a particular county, right?
Second. Yeah, thank you.
So you good?
Yeah, I'm good.
Oh, all right. So let's take this example. So here, they gave us a data about citation from a particular county, and this is a number of citations. So we have the citations, right? Now, when we add all the citations, we get 140. When we divide by 1, 2, 3, 4, 5, when you divide by 5, you get 28. So the mean, so here, the mean is what? 28. The mean is 28. Now we know deviation. So deviation is a value minus a mean. So we're going to do the value, each value minus 28, because the mean is 28, right? So this minus 28 gives you that. So this is the deviation column. All right, so 38 minus 28, then 26 minus 28, the 13 minus 28, 41 minus 28, 22 minus 28. Now, you would see that this is telling you the distance between the values and the mean, right? But we know that whenever you add the deviations, the answer is 0. Now, that is a big problem. Why is it a big problem? Because it's going to be practically impossible to get any other number other than 0 for the average of the deviations, right? So each time you find the average of just the deviations, each time you find the average of a deviation, you're going to end up with 0. Why? Because we were told in math that 0 over any number, 0 over any number is 0. Okay, so the average of these would always be 0. So somebody brought in an idea that, you know why we're getting the 0 is because of the negative sign. So someone said, why don't we square each number, each of the deviation? All right, so we now create a new column, and the reason why we create a new column, because the second row, let's say the second column, this is column 1, column 2. Column 2, the average would always be 0 for column 2. So we need to find a way to bypass that problem. All right, and someone suggested that why don't we square the deviation? So we create a new column, which is column 3, called squared deviations. Now, when you square a number, it makes the value larger, right? Squares make the values much larger, right? Squares make the values much larger. So that is a problem, but at least it solved one problem by removing the negative sign. All right, but let's remember that we've created a new problem by creating the squares, right? But let's forget about that problem. Let's deal with the first situation, solving the first situation. So when you square negative, if you square 10, if you take 10, you square it, it gives you 100. If you take negative 2, you square it, it gives you 4. If you take negative 15 and then you square it, it gives you that. If you take 13 and then you square it, it gives you that. If you take 6, negative 6, and then you square it, it gives you 36. So this new set of numbers, so the squared deviations are, so the 100, the 4, the 225, the 169, and then the 36. So each of these numbers are much larger. Why? Because we've squared the values, we've made them larger. Okay, now by definition, variance means the average of the squared deviations. So the average of the squared deviations is called the variance. All right, so variance is the average of the square deviation. If we find the average of these numbers, the answer that we get is called the variance. All right, so variance is the average of the square deviations. So when we find the average of these numbers, right, the total is this divided by what? How many numbers? 1, 2, 3, 4, 5 divided by 5. That answer is called the variance. All right, the average of the square deviations is the variance. Now, in statistics, we have a special notation for the variance of the population variance, and we have a special notation actually for the sample variance too. Okay, so let me introduce you to the notation before we proceed. So the notation for the variance, remember I said the variance is the average of the square deviation. All right, the notation for the variance of the population is different from the notation for the variance of the sample. The notation for the variance of the population is lowercase, so lowercase sigma. Lowercase sigma is written like this, right? So lowercase sigma, so the population is lowercase sigma squared, right? So that is notation is lowercase sigma squared, or sigma squared. Now the notation for the sample variance is lowercase s squared. So that is lowercase s squared. Now there's another, apart from the notations that they are different, anytime you are finding, remember that what variance is the average of the square deviations, right? For population you are okay. When you are finding the sample variance, you do the same average, but instead of dividing by all the numbers, you divide by n minus 1. You divide by n minus 1. And this is very, very important. I've explained this portion on the last slide. You can read, I think, the last portion of the slide, why we use n minus 1. I've explained it there. You can read it. Okay. But I want to tell you that note that there's a difference in the symbol, and there's also a difference. This is the average for the, and this applies only to the sample variance in general, that you are dividing by n minus 1 instead of dividing by n. Okay, so the problem that we just did, this one, they want us to find population variance, so we divided by 5. If the question, the same question I've said, we should find the sample variance. Actually, let me, I think the next question was that. So why don't we look at the next question? Okay, so this says sample variance, sample variance, sample variance. How do we find the sample variance? So in this example, we have been given the hourly wages of some part-time employees. So somebody gets 12, somebody gets 20, 16, 18, and 19 per hour. So these are like per hour hourly rate. And the question says, what is the sample variance? Okay, remember that sample variance, we use S squared to represent sample variance. And sample variance, one key thing about it, the sum the squared the sum of the squared deviations is divided by n minus 1, one less than. So that is one big thing you got to remember about sample variance. All right, sample variance, there's one big deal. It's very, very big deal. All right, so in this case, let's go through all the step that we need to do. So we have, we need to find, remember, you have to find the deviations first. Then, so that's column 2. Column 1 is always your value, your x values. Column 2 is your deviations. Column 3, it's always your squared deviations. And I've explained to you why we need column 3, because column 2 would always give you a 0. All right, so in this case, we have all the numbers, list the values vertically, find the mean. It looks like the mean, there's 80. So what is x bar? That is, so x bar would be 85 divided by 1, 2, 3, 4, 5 divided by 5. That gives you 17, right? That gives you 17. So 12 minus 17 gives you this. 20 minus 17, 16 minus 17, 18 minus 17, 19 minus 17. So you get these numbers. Now we said that the sum of deviations would always give you 0, so you cannot get the average of this. All right, so we're going to move to the next step. The next step is to remove the negative sign by doing negative 5 squared gives you 25, 3 squared gives you 9, negative 1 squared gives you 1, 1 squared gives you 1, 2 squared gives you 4. By doing that, so these numbers are the squared deviations. Those are the squared deviations. All right, and we need the average of this one. But because we are dealing with samples variance, the average will be n minus 1. N minus 1. So instead of dividing by 5, the way you do regular average, you're going to divide by n minus 1. All right, so the sum of this will be divided by n minus 1. So the sum s squared will be 40 divided by 5 minus 1. So that will be 40 over 4, and that gives you 10. Okay, so that is the sample variance. That is the sample variance. Now, remember also that variance is always in squared units, because these numbers were made larger by squaring that. Remember that I said that the squared unit make the values large. So you've created a problem that you need to resolve. Okay. So let me explain once again here to you what we have covered so far before we get to the next stage. Number one, we've been looking at measures of dispersion or spread, how you could calculate spread, or how you could calculate variability, how you could calculate variation. They are all the same names, right? Okay, we said the range. Actually, let me write it over. Okay, we said the range is one of them. Two, the variance. And I've explained to you that the population variance has population variance and then sample variance has different notation. Population variance is lowercase sigma with a square. Sample variance is lowercase s with a square. Also, what is special about sample variance is that we divide by n minus 1 when you are getting the answer. Is divided by divided by n minus 1. Over here it is divided by n, that all the n's, all right, all the number that you have. So take the major differences in notation and also in computation, how it is done. Okay, now I also indicated that variance is always in squared units. Variance is always in squared units. In other words, the units are much larger than it's supposed to be, because you did square the values at some point in your calculation and you have never undone the square. All right, so now we have to undo the squares. How do you undo squares? You undo squared by using square roots. Right? You see the square root symbol? The square root symbol is like a hammer, right? You use that to hit the number and then the number becomes small. Ooh, that's a nice way, right? Okay, so now brings us to the next component, which is the concept of standard deviation. So the standard deviation, so when deviation scores are squared in the variance, the unit measurement are squared well. So we know variance are always in squared units. Okay, so if people's weights if people's weight are measured in pounds, then the variance of the weight will be in squared or pounds squared. Correct? Now, so since the square units are often awkward to deal with, the the square root of the variance is always used instead. We always use the square root of the variance. The square root of a variance has a special name called the standard deviation. All right. So the standard deviation is the square root of the variance. Take note that. And in general, the variance is the square of the standard deviation. Okay. So standard deviation is equal to the square root of the variance. Okay, standard deviation is equal to the square root of the variance. Now, in general, we have population standard deviation, and then we have sample standard deviation. The notation for population standard deviation is sigma. The notation for sample standard deviation is S. So here, the standard deviation are in the original units, right? So they are in the original units. They are not square units. They are regular units. This is in the original units. All right. Notation for population standard deviation is sigma without a square. Notation for sample standard deviation is S. Because you've taken the square root. When you take the square root, it removes the square sign. Right? When you take the square root of something, it removes the square from it. All right. So it undo the square component of it. Okay. So let's do calculation from the previous data that we have. Suppose the question says find the population standard deviation. You gotta first find the variance, then you take the square root of the variance. So this is step one. Step one, find variance. Step two, find the square root of the variance. That's all. Okay. But how do you go about it? So the same data that we have, the number of traffic citations, okay, you list them. We were able to know how these numbers were obtained. Then we square each of these numbers. We did all this already. Okay. If you are lost, this is this minus 28, this minus 28, this minus 28, minus 28, minus 28, right? If you are lost, you could do this one. All right. Then square each one of these. Then what are we going to do? We're going to find the average of this. It is population standard deviation. So the notation is we're looking for sigma, which is the square root of the population variance. So square root of population variance. All right. So here, the population variance will be this divided by 5. All right, so we're going to say sigma is equal to square root of 106.8. Now, note the 106.8 is in square units, right? So to bring it to the original unit, you got to take the square root, and that gives you 10.334. Now, what is it 10.334 telling us? So that's the standard deviation. It's telling us that the average distance of the values from the mean is 10.33 units. Now, when you look at here, look at the deviations, right? Look at the deviations. When you look at here, it's giving you some idea of how far. So on the average, getting 334 is a reasonable number, right? It's like on the average, on the average distance of how far the numbers are from the mean, on the average is about 10 units. Like each number is about 10 units from the center. All right, think about like a town center and how far people live from the center of the town on the average distance, on the average, if you take like a round perimeter or something like that. Okay, so that is how the population standard deviation is calculated. Why don't we look how the sample standard deviation is calculated? So for sample standard deviation, all right, the same data that we had before, remember that same data, we have this, we worked this already, then you square each one of these. All right, so these are the deviations, and these are the squared deviations, right? So these numbers are square deviations. Now, because the question says we should find sample standard deviation, we are looking for lowercase s. Lowercase s is square root of sample variance, right? So how do you get sample variance? Sample variance, you take this 40 and you're going to divide it by what? 1, 2, 3, 4, 5. Instead of dividing by 5, you're going to divide by 5 minus 1. You do not divide by 4. So that is why we get this value here. And that will be 40 over 4. That gives you 10. So the standard deviation will be square root of 10. And that gives you 3.162. So it tells you that the average distance of the values from the mean is 3.162. So when you compare this one to the one that we did before to this one, you see that most of these values are a little far from the mean compared to these numbers. So these numbers are really doing value distancing nicely, right? No, these numbers are close to each other. The other numbers are a little far from each other. The smaller the standard deviation, the closer the values. The higher the standard deviation, the higher the values. The values are from the mean and from each other too. Okay. Now, as far as I asked you to watch these 3 videos, you will need to watch those 3 videos for you to do the homework that comes from this lesson, the measures of variability. All right, you will need to watch that video. But let me take you through some of the things in that video. So how do you use the TI-83, TI-84 to do problems like this? Suppose I give you this and I give you the frequency and I ask you to find the mean. Let's say I say find mean, find standard deviation, find variance. I say find standard deviation. How do you do this from a data like this? First of all, in your TI, the first step is to go to start, then you go to edit. Now, start edit will open a table. All right, start edit will open a table. In that table, you would see something like, actually, let me put it here. You see something like this: L1, L2, L3. Anytime you do start edit, you get a table like this. Usually L1 are you're going to put your X values. L2 you're going to put the frequency. All right. So in that table, you're going to put these numbers under L1, and then the frequency you're going to put it under L2. So after you put L1, L2, so enter the data values into L1, enter the frequencies into L2. After you have done that, the next step, so this is step 1. This is step 1. Step 2, step 3, okay, but I would say step 2 because step 1 includes this one. Step 2, you're now going to go to start again, but this time you're going to select calc, start calc. All right. Now, when you select start calc, then you're going to select one var start. When you select one var start, depending upon what type of calculator you have, if you have TI-83, when you select one var start, I think they have it this way. It's gonna the cursor is gonna keep blinking. Now where the cursor is blinking, and that is only true if you have TI-83, you're gonna put L1, comma L2. Now how do you put L1? L1 it's second one. Then you put a comma. L2 is second, you press the second key, then you press 2. All right, so L1 is second 1, L2 is second 2. Okay, now that is, then you press enter. So that's if you have TI-83. If you have TI-84, then you're gonna see list. List is your X values. It's asking you where is your X values. So you're gonna put L1 there. Usually by default they will have L1. If they don't have it, do second 1. Then if you have a frequency, the freq list asks you, well, your frequency column, right? So if you don't have the L2 there, you're going to put second 2 to put the L2 there. Then you hit calculate. Now, let me also say this. If you are just doing a question without frequency, if let's say you don't have a frequency, maybe they just say find the standard deviation of these numbers. You put the numbers here, then you got to erase this. You have to erase the numbers here. This should be blank. This should be blank if you are doing a question without frequencies. All right, so take note of that. But in this case, we have frequency, so you got to put the values there. So that is second 2. Then when you hit calculate, it gives you these numbers. The X bar is a mean. So X bar is a mean. Now, another relevant number is the S lowercase x. That is the sample standard deviation. And then sigma with a lowercase x, this one is the population standard deviation. Population standard deviation. So depending upon what standard deviation question they ask you, if they ask you sample standard deviation, you're going to select this. If they ask you population standard deviation, you're going to select that. All right. Take note that these don't give you the variance. But if the question wants you to find variance, then you're going to take the standard deviation and then you square the standard deviation. So when you square, let's say this number, when you square it, you get a variance. When you get a sample variance. When you square this number, you get the population variance. Also, always check your n. This is the total frequency. Total frequency. In other words, when you add this column, you should get 30. It is a way to check whether you made a mistake in your data entry or not. All right, so take note of this. Now, let me say this. If you have a group data like this, then your X values becomes the midpoint. You're going to change this and make a midpoint. So you put a midpoint, let's say 1, 4, 7, 10, 13, 18. So in your L1, you're going to put the midpoints. Your L2 becomes your frequency. Okay. And then you just do the same thing. So after you've entered the data, you go to start calc, then you select one var start, then you put in your L1, L2, and that. All right. So that is where I want to end here. This summarizes all the notation we've done. Sample variance is this. Population variance is this. Sample standard deviation is this. Population standard deviation is that. All right. So that is the end of the day. Large standard deviation means the data is very spread out. Small standard deviation, there's a little variation. Okay.